In this video, we will cover how to use functions in zcashd to verify the sender of an anonymous shielded memo to the degree that they hold a specific private key. It doesn't let you know who they are exactly, but that they hold the key of a specific receiver of a unified address. Now, these functions existed in the protocol before, and you could sign messages and verify them. But with unified addresses, you can now correlate ownership of the transparent address with the shielded address without any need to give them that address prior to, or let them know that it belongs to someone specific. You don't know, in this case, potentially who holds the key unless they want you to, but you can verify that it was, in fact, the key holder who signed and sent the memo. And as you can see, we're running zcashd. Let me go to the CLI. Okay. We will run sign message help, and this will show us what we can do. The sign message function takes in a transparent address and a message, and it will return a signature. The verify message function takes in the same things along with that signature and will return a bool, either true or false. You need to be in possession of the spending key of the transparent address in order to sign the message. There is an example on Zec pages, here we go, with this unified address here, this lower part. This is the signature, the highlighted part, and then this is the message that was signed. Now, to get the transparent receiver of this unified address, we can copy and paste it in simply to the block explorer, which has the list unified receiver function already in there. And actually I already did that. Yep, here it is right here. I'll paste it just to show you. Same thing. Okay. Here's the transparent address that signed that message in that memo. And here's the shielded address to which you could reply to, or simply the whole unified address. But this shows the association of ownership of this key that signed the message with this key and this key. So, to verify this, we're going to use the verify message function. We're going to copy the transparent address. Oopsie. Sorry guys, not the best mouse here. There we go. Okay. Verify message. I'm going to paste in the address that we copied. Going to paste in the signature contained in that memo, which is this guy right here. I want that leading space. All the way to the equal sign. Oops, wrong one. Go. There we go. And the message. Make sure that's correct. Yep. No spaces. And as you can see, we get true, which means that whoever owns the key to this address, the receiver of the full unified or partial unified address, excuse me, signed Mr. Example, that there wasn't any sort of foul play in this, and that you know specifically you can reply to that address and will reach the same person who signed that memo. And you can do that now with unified addresses with no more than this. You don't have to tell them, oh hey, here's my tatty, I'm going to sign things with it, or give them the UA. You can get the receiver and I'll sign things with that. And you can do that, obviously. Beyond this now, if we were the receiver of this particular memo, we would save that address, this address, and then any further memos that contained a signature, we could check against that and see that it was in fact from this same person. But that's about it. I know it's kind of clunky to do in Zcash. I have a program that I wrote called zclimate that will do certain things very easily for us. Some of those being sign and verify messages, along with sending and listing addresses and transaction history and stuff like that. We could very simply, oh well, this is the sign message, excuse me. Here, we'll sign a message. We'll just pick this second one right here, number 2, and we'll just say hello. Alright, and there's our signature. And then we would go through the same verify message function to verify that, but we'll go ahead and re-verify this one. I'm sorry, what did it ask for? The address. Oh, dang it. Paste it in the signature. Why did, you know, the silly things sometimes. Let me just take care of this. Oh, as you can see, it was invalid, so we were alerted to that fact that it was invalid. It was not the case this time. See, it does not have the equal sign there at the end. Equal. And then the message. True. Oh, what did I do? Did I put a space there? Let's try that again. I'm just gonna get the signature right off the thing. No more typos. See, sorry, that was a typo on my end somewhere. Oh yeah, I got the wrong signature. It's completely wrong. Oh, sorry, copied it from up here. Sorry about that. Okay, here we go. Yep, see, true. There you go. And now, I suppose if you knew who that person was, you know, or later on pass more information about, you know, then you can know. But really, it doesn't matter. All that we know is that the holder of the key to this transparent address signed this message, and the transparent address correlates inside of the unified address. So you know exactly who to return to. You don't have to trust a reply to address. It's, you know, it's verified. Obviously, the key could become compromised, you know, from bad operational security. and then it's a whole different thing. It wouldn't work. Obviously it could be jimmied, but as long as the key is retained by a single individual, then you know that you would be communicating with one single person, even though you may not be knowing who exactly they are. Alright, that's it. I'll go ahead and stop here, and I will see you guys next time.